Good morning or afternoon, whatever time it is for you. Welcome back to the Fire Break. I'm Steve Wolf. As you know, the Fire Break is sponsored by Team Wildfire, developing innovative technology for wildfire containment and control. That sounds like a lot of ambition, but we got some of that here. I've got a really cool guest with me today. I've got Scott I just said it right before, and now all right, Pokswinski. Did I get it right?
That's it.
Pokswinski, thank you. Scott's a really smart guy. He's the director of fire science applications at the New Mexico Consortium, which includes some pretty cool labs, right? Scott, tell me what you're working on, who you're working with.
Yeah, so we're really sort of a integration piece, multidisciplinary group. New Mexico Consortium links Los Alamos National Lab with a lot of the universities in New Mexico and some other universities to sort of create innovation. And so the part of the group that I'm in, there's stuff from space and physics, and my group is the Center for Applied Fire and Ecosystem Sciences, 𝐃𝐨𝐧'𝐭. And so our group, we have cultural resource folks, and we have conservation folks, and then my group, which is the Applied Fire Science group, which essentially takes the latest technologies and translates that into tools, and we build tools essentially for next generation wildland fire management.
And to take nothing away from tools, because I'm a huge tool head myself, but to what degree do you think the solution, so to speak, to the wildfire problem, which is wildfire destruction, lies in new technology versus personal actions, personal responsibilities, and changing thoughts around wildfire?
Yeah, that's a great question. From our perspective, there's definitely a need for sort of attaching ourselves to the human element. And first of all, everything we do is really about, all the tools that we build is really about putting more fire on the ground, a lot of prescribed fire and all that kind of stuff, but also doing it safely. But then the other part of it too is, we work with a lot of anthropology groups, so that we're talking about, like, how do we change attitudes? So like out here, so I'm a Westerner. I grew up, spent most of my life in north of Seattle, and then moved down to the Southeast, and that was really advantageous for our research because there's a culture of fire here, right? So
Yeah.
One of the major reasons why when we have escapes or wildfires, the numbers are in the hundreds of thousands in damage versus hundreds of millions. And so a lot of that is because you have a century and a half of fire culture, and so fire is always on the ground. We get, as we are just now kind of in the middle of prescribed fire season here where I'm at in Florida, and it's been smoky recently. And so, everybody on Facebook and our local Facebook groups are always talking about, oh, it's eggland burning, or it's Blackwater State Forest burning. And it's, like, what's up with it? Because we're a military community here. And so there's an influx of culture. And so, the question always is, oh, what's all this smoke, and where's it all coming from? And the locals are, hey, like, this is this time of year, just, be ready for it. And so there's this
Prescribed
acceptance.
smoke, right?
Yeah. There's an acceptance. Yeah.
And where are you?
I'm in Crestview, Florida, which is just north of Eglin Air Force Base.
Okay.
Yeah. So right in the kind of in the middle of the panhandle.
All right. So do you think that people think about prescribed fire the way they think about vaccines? Like, well, yeah, this could do a lot of good, but there could be side effects, so we shouldn't do it.
Yeah, no, that's a great question too. I know, I came into fire from sort of the research angle, and then became more involved in the operations side of things. So, I was indoctrinated with the ecological, from my degrees and all of that from the ecological standpoint. So to the first time we were on on a fire, and a local rolled up and like, kind of started kind of like asking questions, not in a friendly way. It was a surprise to me, because like I had been through my university's experience was, hey, fire's great. It's part of the natural system and all of that.
Right.
There are things like, my sons, can have asthma, like, we're dealing with, a lot of lung stuff's going on this time of year,
Right.
as well. And so, asthma is a thing, and I get that, but there are reasons people would be concerned about smoke, and one of the things that we do sort of in building these tools, you asked, sort of culture versus tools, is to kind of look at, okay, how do both wildfire, I say wildland as a general, for including prescribed and wildfire, right? So, but wildfire and prescribed fire, like, how does our smoke impact communities? How does our smoke, how do we mitigate that? And so, with some of our partnerships with, especially Lanel and some others working on these next generation fire models that are spatially explicit, we're building these fire models that also include smoke models, so that we can say, okay, during this burn window, we can expect the smoke to go in this direction. And how do we then say, okay, there's a community here with a school and a hospital, and how do you thread that needle, right? And so that's, building tools helps us to mitigate those factors that might be of concern to the general public.
So is the options on the menu are chronic low-level smoke or occasional catastrophic unsurvivable smoke?
Exactly. And we have partnerships and collaborations with, like, EPA. And so when our research burns, we've got, everything from big telethon balloons or UAS carrying their PM 2.5. That's, so essentially particle detection, and looking at, like, the difference between, and these guys go out to, oil rig fires, and they go out to big wildfires. And so we're always kind of comparing those and saying, okay, what is the difference and we can talk about carbon and we can talk about all of these things, but what is the impacts? Because there's some impacts in all fire, right? Like, there's positives and negatives. And so, where does it make sense? And when is the tool, you say you're a tool guy, I see the pipe wrench in the back, I see all I come third generation tool guy. I spent time between my master's and my undergrad, 6 years, hawking tools, for an industrial supply house. So, like, putting the right tool for the right job is important. And prescribed fire isn't always the right job. Out west, it has to be done, fuels mitigation has to be done. There's a combination of that, and there's pile and burn, and there's, mechanical, and all sorts of methods that we have in our tool chest. It's about finding the best tool for the job. It's about building new tools that help us to understand when a tool might be better used, and then also sort of bringing it together in an ecosystem of tools and technologies.
Right, and matching the cost of the tool.
Yep.
Again, right.
Yep, exactly.
The best thing, right? Cut down the veg you want to remove, put it on a truck, move it far away from everyone, and burn it.
Yep.
Or bury it. Right. Yeah.
Exactly.
But
yeah.
Right, but that's not always possible.
And it's, there's a spectrum, right? So, like, here it's, if we're just doing, got hand torches and, a team and just a little manpower, and we have good containment, then you're talking about, dollars an acre for prescribed fire. But then if you're talking about having to go and do mechanical removal and manage those fuels, then it gets into the thousands of dollars per acre. But then that doesn't translate everywhere, right? So that's really what kind of this is about. It's about trying to do decision support.
Okay, so you have decision support at the project level, and then you have decision support at the community level. To what degree do the community support your decisions?
Yeah, so the like I said, there is some there's concern here in this community, even though this is but for the most part, it's support. And then, there's, like, I said, I'm from Seattle. My parents just put their house up, and they're moving to Redding, where they just purchased a house, and of course put themselves right on the WUI. And you're just like, did you not consult me? Like, I do this for a living. We can talk about risk. I've got access to risk models. Why did you buy that house? Anyway, no. But there's, like, that Mediterranean, like never burn, never worry about fire. And then you move to a place where you do now start to have to, but then there's not been, after years in suppression and the spreading of that WUI, people don't understand because, A, they're moving in from other places, or B, we've been under years of suppression. And so now we've got this situation where there's a tremendous amount of fuel on the ground. And, managers are looking to each other like, I'm not going to put fire on the ground. Are you going to put fire? No, I'm not going to put, right? Like,
right.
Or how do we then say, okay, here is, and honestly, we're looking at sort of a volatile, natural hazard situation. And so, how do we then provide the tools to help those decision makers and operational firefighters decide, okay, how do we then mitigate these dangers? And how do we say, okay, we've got these tight little burn windows, or we have these tight little times to be able to, or the limited resources, how do we make the most out of those resources or time periods or whatever?
Yeah. So how do you overcome fear of putting fire on the ground? Right. You could have 100,000 successful prescribed burns, and you have one getaway, and now all of a sudden, it's like, no, you're not doing that in my neighborhood.
Yeah, no. Los Alamos is an example.
Yes.
There that definitely is a concern, and you do have to kind of mitigate. So for us, it's about building better fire models, building better smoke models. My discipline is I'm a botanist by training, and got myself slid into fire somehow because all of us who love fire end up here, I think.
Sure.
So since a young boy, staring into the fire at the campground and poking my stick into there, eventually it was destined.
Yes.
But you make your way there. And so like, for me, it's about fuels, and it's about monitoring of fuels. I use my program is that I manage is the 𝐸𝐿𝐵𝐺 program, which is the interagency ecological LiDAR monitoring program. That's
rolls right off the tongue.
It does. It's actually, I'm also like an old school 80s video game nerd. So it's kind of a play on the old Intellivision, but I'm a dork. Sorry. So it's essentially, being able to go out and, like, right now, what are we doing to monitor these conditions, right?
Yeah.
You've got tools like Landfire that are remotely sent, a lot of remotely sent stuff. Just whether that's airborne LiDAR or but it's all kind of at this core scale. And so with this new understanding of how fuels are, we have to have this understanding of vertical fuels continuity, and all of these sort of complexities. We looked at what we have, and we looked at, like, okay, how do we build a program and a monitoring program that helps us to not just, you said before, here's the resources we have, a monitoring plot like a Brown's transect for those old school fire folks that are out doing some fuels evaluations, take hours and hours of man hours to go do per plot. And so how do you then get enough on the ground? And so, we developed a system, that uses these little terrestrial LiDAR units, that, anybody can go out to the woods and push this button. And, next thing within a minute, you have 12 million measurements, right? And so being able to take those points, upload these into USGS's AROS data processing center, and within a day have your monitoring data done, right? So, being able to sort of make those measurements, so you can start to say, we can start making those connections to Landfire, which we're currently doing, so that their models are better, so that the risk models are better, to say, okay, in this condition, like at the project level, decision support, we need to know, okay, what do we prioritize to manage? What are the likely what are the likely tracts of land that are of concern and would lead to the most damage down the road? And so, those sort of integration pieces with the fuel modeling folks, with the new fire modeling folks, all of this kind of comes together into this ecosystem that we're starting to build. And so it's really an exciting time, but it's also kind of a scary time, because it's kind of in its infancy. All of the fire models that we're currently using are all empirical, and they're based off of early 70s raw thermal, which is awesome. It's he's amazing. He's like, you got to go come up with a wind component. He's like, I'm just going to write a whole fire model because I have to, because and
right.
and we're using it here, for operational wildfire, and honestly everywhere here in 2025. But understanding the spatial explicitness of these fuels, and then how do we then turn these into fire models that we all have in our heads if we've seen in a fire, right? So that's kind of the trick, and especially is in this world where we have this aging, and we can talk all the time. I'm sure on your podcast people talk about mentorship, but mentorship happens in fire. But as we start to age out, like, how do you get that knowledge fast? And so using these tools for training, using these tools for decision support and understanding, like, a new guy who's never seen fire before, I've seen a lot of prescribed fire. I've seen a few wildfires. I have the advantage of being able to say, okay, I think I know what the fire is going to do based off of a rate of spread and, or what my conditions are. I'll look around and be like, okay, these are my watch outs and I got to watch for this sort of situation. Versus someone who's fresh 18-year-old on the line has no idea. And, when someone says, oh yeah, rate of, in the briefing says your rate of spread is going to be this many, chains per, what's a chain? Chains per hour. And here's your, flame lengths. And,
Is that a metric chain or imperial chain?
So to me, yeah, right. Like, what is that? A chain? Well, I'm a scientist, so it's metric. No, but which breaks up nicely into 10 and 20 meters, half a chain anyway, and a full chain. So yeah, it is metric. But it's like, how do you download that? I've seen 100,000 fires into the, I'm, fresh, these sort of next generation spatially explicit fire models are maybe that way. And so linking these sort of visualizations into VR for training, it's on the horizon. We're a part of some of these really cool connections. And so, yeah, that's really kind of where I kind of hang out is, what are the latest tools, UAS, airborne platforms, satellite platforms, small, terrestrial LiDAR units where anybody can go out and push a button. Who uses that
LiDAR unit? I imagine this could run like a SETI program, right? You send the LiDAR out to people, they take a measurement, they send it back to you, you send it to someone else.
That's it. Our Intellimon viewer currently, we're only a couple years into this program, 3 or 4 years into the program. We have like 5,000 plots all over the US, some in Belize and some other places. But it's available to scientists. It's available to everybody to come and get this data and start to look at it, monitoring. My plan right now, it's really focused in the Southeast, and we've got some California and we've got some Washington State and, Front Range in Colorado and a few other places. But my plan is to make dots all over the map, and that'd be a valuable resource for researchers to say, and honestly, risk map, and risk modeling folks to look at that stuff and say, okay, here's the fuels that this LiDAR model predicted will be here. Can we compare that to strata like Landfire that are looking at, remotely sensed products and say, okay, we might need some tweaking on our models because this is the actual on the ground. And the cool thing about TLS and why we use it is because it's a really visual medium. We can look at a 12 million point cloud and look like you're sitting in the middle of the woods. And so, there's a lot of skepticism from land managers and firefighters when they see a land fire tile. It's like, okay, well, that's remote. I've been in some and they've been wrong. But, if you can put that data with the visualization, which we do have a partnership with UCSD, UC San Diego to build this awesome product. And like they can see their data, like the tree diameters on the trees sitting in the middle of the thing, and they can click through monitoring plots. And they can see the change, and it's saying, well, this reduced this fuel in this layer, and now they can click through and be like, okay, yeah, I believe that, because it's a very visual medium. So it's
seeing
a really
is
cool
believing,
tool.
right?
Yeah, exactly. I have I had to learn all this, because in grad school I had an old school naturalist advisor, and he's like, yeah, your stats, you took stats in undergrad, you're good. And he goes, never asked me about it. And so, but he was also a poet. And one of his poems that he would always do is data set. The SH is for show me, the IT is for it. Because, it's like, I need to see it. I need to see, the numbers are great and cool and important, but a model is always wrong. And so how much is it wrong by, right? So
when we use, and I'm going to use remote differently, remote meaning like far away from me. So I live in the foothills in Colorado.
Okay.
And I see prescribed burns, on the horizon all the time. My thought would be, if I'm not smelling the smoke, it's not reducing the fuels in the area that are going to impact me when they burn. So they're very comfortable, doing prescribed burns in areas where they're making a fire break between two pieces of unoccupied land. But if they're not making a moat around the community, then they're really just practicing their skills. They're not making the community safer.
Yeah, that's a tricky thing, and it honestly, there's a push in the Southwest and a little bit in the Northwest for these. In the Southeast, it's really common to have prescribed fire councils and prescribed fire sort of local. I mean, like one of the easiest thing for a Florida, it's written into our Constitution that I have the right to burn my land.
Okay.
And so not only are these federal lands burned, but there are these, prescribed fire councils and prescribed fire burn, associations, PBAs, that are coming up that are like just you and me. I'm going to go burn mine. I'm going to go help you next week to go burn your spot, because and here in the Southeast we have the preponderance of land is private. It's not public. It's not like the West where we have huge tracts of public land, and so here they've been burning. It used to be in the old days that they would go out on their horses and drop kitchen matches and let it go, and then so your neighbors would be catching those. Would be the catcher's mitt, right? So the risk right now is tricky because they don't have enough tools. They don't have it's tough to make the argument that this somewhat risky burn is outside of prescription, and the prescriptions are really narrow for a reason, because of situations that have already happened, right? So then you have you have these tight burn prescriptions that you may or may not get, and so it gets tricky and risky. And so the other old joke is what do you call a burn boss in a suit? A defendant, right? Like that's the attitude out West, and so being able to build, start to give back with some of these tools and say, here might be an opportunity for you, and take this opportunity so that you can start building in that sort of catcher's mitt around the community. So when you get something that's inevitably going to happen, it'll run into it. Then there's the other path, which is maybe prescribed fire is not always the right tool. Maybe it's another more risk, or less risky.
Maybe it's goats.
Yep, goats. Maybe it's goats. I mean, California's I might start investing in goat herding. No, but goats or piling and burning, or just other mechanical treatments, or might be the path to go. And so
Agent Orange. There we go.
Yeah. No, that's something when we're doing work on Eglin Air Force Base. That's it's an old test site. There's Agent Orange, but it's interesting. So being a researcher in the Southeast, I'm really spoiled. I'm able to be on fire almost at any time. We had scheduled for this next week, we were going to be at Merritt Island, at Kennedy Space Center. And the idea was to have NASA Fire Sense come through with all theirs. We're going to have 130 scientists on this research burn. And the plan was to have this burn so that we could validate some of these next generation smoke models, because, you have all these buildings that have spacecraft in them, and the spacecraft can get, how many parts per million of smoke to get on them. It's a bad thing. So we have to split the uprights. Like, oh, there's SpaceX and there's Blue Origin. We got to send the smoke right down the middle. And so they're really interested in this. And unfortunately, in the very rare situations, we have a situation where we're now under severity. And so that burn had happened to get bumped off. But then we have partners that do a lot of prescribed fire at Fort Stewart. And so we're just able to pivot. And so now we have 130 researchers. Like any in the Southeast, I can put fire on the ground, even in severity, if I have enough good partners. So whereas out West, it's a little bit trickier, but it's really it's also, to me, interesting in a different way, because these models are going to have to be calibrated and validated for those fuels. And so building these Western partnerships is going to be critical for that, so that we can start to say, okay, yes, we can maybe widen those burn windows, where right now it's like we're being very risk averse. We want to now spread them out a little bit by saying you can, because under these certain conditions, you might be able, it might not be that you can burn that entire window, but hey, here's an opportunistic slot when the RH drops down just enough for you to be able to burn. But then, and then the other part of things are tools, right? So, we've got, looking at being able to create, create situations where you can burn when you normally couldn't. I've seen your guys' stuff, and I've seen, there's another startup here in Florida that was looking at something similar with putting, essentially we have these fan boats that are flying around. And so the idea would be, putting a fan on a turret and that, so there's, from a prescribed fire perspective and a person who builds tools for prescribed fire, let's say you have marginal conditions, you can't get fire to go, maybe putting a gust of air on it would be awesome, because then you could light it, let it go, and then you can turn it off. Right. So now the fuel moisture is enough that it isn't going to carry fuel past what you tell it you want it to. So, like BurnBot, that's another example, right? Like, these guys are innovating in ways that, let's figure out an efficient way to put these fire lines down. And BurnBot's kind of a cool little idea. And so there's all these sort of interesting ideas and plans, and you guys too, right? So like all these cool, interesting ideas to not, that are thought of for suppression, but also potentially for treatment.
We think of our jet engine for, basically you could lay out a 500-foot wide necklace, of barrier around the area where your prescribed burn is going to take place. So to have, once, the problem is those things have to, I'm not saying problem, it's not a problem. It's the opportunity is that we have to start implementing those things. And then once, you're, here in Florida, we have to call in to get our state burn number. Once the state has worked with you enough to get a variance, or the state is like, it's Scott, he's going to burn. And then we've never had problems with him before. Then you can start pushing the needle. And then you also culturally have to build that culture up. Right. And that comes with, with community meetings and town halls and like, explaining and stuff like this. Right. Like, getting the public to understand, what it is we're doing, what the benefits are. And yes, some risk, but also, what the benefits are. So, it's a complex, definitely multidisciplinary approach that we're taking. Well, maybe we think about fuel load as something that one could violate, right? I'd have to take my car in, and it's not allowed to emit more than a certain amount of crap, right? Or, if I happen to have the misfortune of living in an HOA, Mrs. Birnbaum comes over, is like, your lawn is a half an inch too high, you have to cut it, right?
Yeah.
So maybe we think in terms of fuel load there as well. Like the fuel load on your property is too high. You're in violation of the fuel load per acre, ordinance, and you have to mitigate that.
Exactly. Yeah. No, it's there's several approaches. There's the carrot and the stick,
right?
and sometimes the stick can be a little tricky. But that's that sociology sort of isn't really my bend. So that's why we have sociologists on.
If you can't put it on a tool bench, right?
Yep. Yeah. I mean, right. Like so yeah. That's it's something I'm definitely interested in but it's always I'm always surprised when I'm out on a burn and someone's like, it just sort of it's what I assume everybody knows, but it's like, oh yeah, like there's a negative, when we started at the New Mexico consortium and brought our fire stuff in, and a group of us came in and said, we're going to start this group. They're like, wait, you're going to be around fire? There was a lot of concern because of their, they've had a couple of near misses, and and so that's the public. And I'm always, like I said, I'm always surprised because I've, for the last 30 years, I've been, good fire is good, bad fire is bad. But, and so just understanding the difference it's not just common knowledge.
No, that's something that requires a public education campaign.
Yep, exactly.
And many of them, right?
Yep.
Tell me about the opportunities around prescribed burns for testing new hardware. perhaps even on the suppression or containment side?
Yeah. So, like I said, the advantage of being in the Southeast is, there's always a fire, and I my previous position was at Tall Timbers Research Station, which is it's where they invented the term control burn back in the years and years ago, Henry Beadle. Yeah, we get calls a lot, with ideas and people wanting to try out, because like I say, we can put fire on the ground anytime, and we had 4,000 acres, and yeah, it was kind of a cool little place for people to go and try things out. I had a sandbox where I could, essentially was a big just sand that we put down pine straw, and we'd do all sorts of research burns on my sandbox. And so, with that was all instrumented with FLIR and GoPros, and surrounded by all sorts of imagery, and so it was kind of a cool thing to be able to work in the Southeast, where it's not just and the folks at Rocky Mountain Research Station have burn chambers, and same with the Southern Research Station with the Forest Service, but be able to take it that next step out into the woods where you have some complexity, or into the next step really is into something like a sandbox outside. We're adding some complexity, and then being able to test those kind of tools. That's going to be important, because you're going to need to be able to show, or someone who can be kind of skeptical and say, here's where we've done it. Here's our evidence that it was a successful deployment, and that we reduced risk, we increased safety, we reduced effort, and increased efficiency. Those are the kind of things that you need as you build a tool. We're talking about the right tools for the right jobs. You have cost. You have to get a couple of these things. Just being able to reduce cost, but not increasing efficiency or power or speed, then that doesn't help you. You need to be able to show that you can do several of these things. But being able to show all of those things to then say, this is the right tool for you, or maybe you should consider using this tool. That's something that if I'm fortunate, and all my stuff doesn't necessarily require fire on the ground, except for the validation of these fire models.
Okay.
Most of our stuff, I still have that skepticism with even this beautiful TLS point cloud that we can show, and put you in it. There's skepticism with every tool, and you have to be able to show that. And so being able to find your pilot locations and your partnerships really kind of key and important.
To what degree do you think the complexities that happen, in real world burn are informing how we do the lab burns? Are we able to make the lab environment more complex so that it more closely resembles real world conditions?
So to kind of give you an idea, most of our operational fire models that we're currently using are all burn chamber based. So Rothermal, was all based off of empirical numbers that they drew lines between data points to create that model. So it's all based off of burn chamber. But the reason for that is there's assumptions like, consistent fuel bed and fuel loading, constant, wind speeds and things like that. Whereas the outside world is really complex. So it actually does not translate well back that direction. It's a great place to start. So, an example that we did was to have, to do things like partnering with we had two different DoD startup grants that looked at, one was taking a burn chamber and going exponentially larger. So I don't know if you've ever talked about IBHS in South Carolina. Carolina. It was just gigantic, and I've been in it. It was crazy. This wind tunnel that is just this big. It's a gigantic wind tunnel that is apparently Duke Energy only lets them have it turned on for a few hours a day, because it's like
brownout conditions.
They have brownout conditions because it's just huge. But they put whole houses, they build houses, leave them outside to weather, and then bring them in and burn them. Right. So it's huge. So being able to make that transition from little burn chamber to gigantic warehouse with hurricane winds, that's a step there. With a separate startup project, we had them do internal burn chamber work with Worcester Polytech. And then we built a mobile in situ burn chamber without a floor. So you have a wind tunnel, So it was a wind tunnel that could be picked up by a telehandler and moved in the woods. And so we could sort of control some of the aspects, but now we've got a natural fuel bed that's real, right? So it's like taking those steps as a tool developer or researcher. And when we're validating something like a physics-based model, we have to iteratively add complexity. And it's usually starting with the simple and going that direction. It's really tricky to add complexity the other way in such a confined space, right? So that's really I think that's the approach that we've taken and have been somewhat successful.
I know it out at I visited Oak Ridge National Labs, it's out of Knoxville, and some of the work that they do is so equipment or electricity intensive that they're building their own on-site nuclear power plant.
Right. And fortunately, IBHS, because they're owned by they're not owned, but they're funded by the insurance companies. They have deep pockets, so they can just pay for Duke Energy to send them the money, send them the power. But yeah, it's an interesting sort of problem to be able to scale to, and then it's funny because then the cost goes up, but then it drops back down. Like if you're having a burnout here in the Southeast, right? So where it's, like I said, dollars per acre to put fire on the ground versus, hundreds of thousands.
So I'm curious, this is less of a science question, more of a money flow question, although they're related. So when you have a conflagration that impacts a community, the community pays the emotional price, the insurance companies pay the financial price. And so given that the insurance companies are ultimately the ones who have the highest financial burden related to fire, why are they simply influencing, codes rather than leading the charge of suppression technology?
That's a great question. I bemoan sort of similar stuff with our development on the development side. We've been working on these new fire models for quite a while, but there's only so much resources that go towards it. And to kind of give you an idea, it's essentially like at some point you have to decide to make the jump between DOS to Windows 3.5 and then Windows 95 or whatever. But right now what we're at is we're at DOS, and honestly that those fire models were created when punch cards were being used, right? So that was the inputs. So these these paper cards with holes punched in them were the inputs. You didn't use a keyboard. And so, now we're here at Windows 11. That's like now the jump that we've made. And the problem is we don't have something like a corporation like Microsoft that's like, okay, time to dump in the next, throw billions of dollars at the next version. And so, it's tricky. But at some point that's going to have to be that there's going to be a need to translate and say, we need to make partnerships with like we did with this IBHS group, but the insurance companies themselves, and say, hey, look at Florida when we had that prescribed fire or that jump in that took out a little small community in 2019, I think it was. That was like $1.4 million to take care of, whereas in California we're looking at 114 million, right? Like exponentially more. And sort of come back and say, well, we're talking about research dollars in the 10 million we'd be flush and we'd be building these tools, and how much impact would these things have, maybe proportionally, right? Or something for like for training for and safety for suppression, or whatever connections to suppression we have, being able to say justify, let's increase in efficiency, operations, and decision support for and just being able to make those jumps, but then also doing it wisely, right? Like not investing in solutions looking for problems, but also saying, okay, this is something that has real clout and we need to kind of and support it, right? And so in our world, it's like right now, to combat that, we were asked by Northern Arizona University to develop a course for the tools and technologies of wildland fire, because and they said, Scott, we want you to work with us to build this course, but what's the vision? And I was like, so our name is out there in the land management world. And so I get managers come to me all the time and say, hey, we got this plug of money. I want to buy a drone. What can it do? It's like, okay, all right, let's sit down and talk about it
first.
Yeah,
right.
Exactly. Yeah. So, to me, I was like, we do, all of our work is co-production. So we bring early on in that stage of the building of the tool, we bring the land managers in and we say, okay, if you come in now and you let us burn on your sites and develop the models for your site, that gives you a model that's more accurate for your site specifically, but also helps you drive the tool development, right? And so it makes it so that we're not building a tool, because if you just let me go at it with terrestrial LiDAR, my monitoring program would look completely different if I did not involve these managers and sit down and say, let's build a monitoring program for you to talk about how we would reduce fuels. What's your thresholds and what are your different ways of measuring fuels? And so we can work that into the program and all that. So, being able to, make those connections. So for us, that class was about training people, like, here's a tool, here's how it can be used, and here's what you get, so that now land managers aren't coming to me with, questions like, hey, what can I do with a drone, or what can I do with a terrestrial LiDAR unit, or what can I do with an airborne LiDAR flight? Now they're saying, hey, I'm going to fly this airborne LiDAR flight. We need to know, we've got these archaeological sites on site that might be affected by our fires or something like that. How do we spot them? Can you do that? So they come to us with the problem, and we build the tool around it. So that's a real exciting. It was a fun thing to build a 5-course certification at NAU, and I encourage all of you listeners out there to go check it out. You can get a certification in the tools and technologies of wildfire at Northern Arizona University.
Can you do that online?
It's a 100% self-paced course, or 5 courses, and it looks at a broad range. So it's like there's a cultural aspect where we look at archaeology, and we have archaeologists in our team that do that. We have conservation, we have decision support, fire modeling, fuels, and all that kind of stuff. So it's a kind of a cool course.
I'm going to take it.
Courses. Yeah.
That's cool.
But that's a fun little. We try to look at things holistically, right? And the same with the monitoring program. We've got training built into it, and so we've got NMC, and cafes. We have a trainer that helps, train the people in the use of these tools, help them to understand the tools once they're built. And so, that's kind of the, being able to look at a problem holistically and say, where does this tool fit in, and how does that, how do they work with other tools as well? So
I wonder, if you choose a tool based on what you think it's going to do, and then it has to do it reliably.
Mm-hmm.
Why would you be on a Windows 11 tool instead of iOS Sonoma 14.6 tool?
And the funny thing is, I'm because of my scripting and coding really works only on Windows, and these units do, and I'm kind of ridiculed because our both Lanel and the NMC shop are all Macs, and so I've got my MacBook sitting right here, and I've turned on 3 times, not because it's not a really fast tool, but because the Leica, the brand who makes these units, their software is Windows only, and it doesn't work on DOSBox or anything like that. So it's like, it's funny how it like you have to go down these paths and it guides you.
Right.
But
right.
Yeah.
Funny. So we have proven that any conversation can come down to a Mac versus PC argument.
Yep.
That's pretty funny. Scott, give me the link again for folks who want to take that class.
Yeah, it's
or if you email it to me, I'll stick it up here.
I'll email it to you. It's Northern Arizona University distance learning, and it's one of 2 certifications that they have. They have a greenhouse accounting certification, a greenhouse gas accounting, and then they have the wildfire tools certification, 5 classes long. So
okay,
and they're slowly rolling out. Right now, I think we've got class 1 and 2 up, and 3 is being wrapped up. Is being wrapped up, in 4 and 5 will be shorter.
Well, I'm excited to try those out.
Yeah.
Awesome. Scott, we have a lot more to talk about, so I would love to bring you back again so we can, jump deeper on this. But thank you so much for joining me today. Scott Pokswinski, Got it right this time.
You did.
Good.
Yep.
Awesome. Practice makes consistency.
Consistency. There you go.
Right. Only perfect practice makes perfect, right?
Yeah. And like I say, I'm like 4th or 5th generation removed from Poland, so I don't know if I'm pronouncing it right, but that's how.
All right.
That's how we pronounce it.
Okay.
So consistent. That's literally right. It's consistency, not perfection.
Great. Thank you, Scott, so much for joining me. And thank you all for listening, watching, and joining, however you absorb this podcast. You've been listening to The Fire Break. I'm Steve Wolf. The Fire Break is sponsored by Team Wildfire. Till next time, be well, take care, put some fire on the ground. Do it safely.
There you go. Yeah. Thanks.